So thank you all for coming again. We're going to do this session on additive manufacturing. And Mr.
Just a question, is it recording?
It is.
The green light isn't, okay. Green light on the camera's on. The next one, to the left.
Oh no, that's to share that's a webinar. Yeah, so the webcam. So our presenter today is Mr. Tim Fahey, and he is our additive manufacturer cluster guru at Team Neo. He's got 25 years of experience in the industry. He's the former president and CEO of 5-Star Technologies, the former leader of static control business of Novion, formerly BF Goodrich. He's led several technology groups at BF Goodrich, Raychem Corporation, and Lonza. And he is an expert in conductive metals, technology deployment, and market entry. He holds 11 U.S. and 6 international patents, which is just incredible. And he's also got a Bachelor of Science and Master of Science degrees in macromolecular science from Case Western Reserve. All right, I'll let Tim take it away.
Thank you. The next slide there. So at Team Neo, as Erica said, I co-lead the additive manufacturing cluster that's in partnership with the Youngstown Business Incubator. So Melinda and I and Barb Ewing, the CEO of YBI, we facilitate steering committee to help us guide that cluster and working groups, and it all is about executing the initiatives that grew out of a roadmap we did about 2 years ago, mapping out the assets in the region related to additive manufacturing and what we should do about facilitating those assets and improving the competitive strengths of the region in additive manufacturing. There's a number of funded programs that I work on as a subset of that. One is that I am an entrepreneur in residence in the Jumpstart ESP network through YBI. And so I mentor the startups in Northeast Ohio in additive manufacturing, currently mentoring about 12 startups in the region. Second is there's a program I'm going to tell you a lot about today called ATAP. It's about advanced tooling using additive to make tooling and jigs and fixtures in your manufacturing environment. We have 2 Burton D. Morgan funded grants. One that Team Neo leads, which is I do outreach to the LaunchNet programs at our universities in the region to try to engage students in our clusters especially if they're thinking about starting a business, spinning a business out from what they work on, then we can introduce them to supply chain partners and mentors in the clusters. The second one is administered by YBI, and that's about specifically working with companies that got funding from America Makes to take technology to market but haven't quite gotten there. And so we're assembling student teams so the students will have part-time jobs working as a commercialization team for those companies in the region. It's a great program. And then lastly, I do work on identifying additive manufacturing attraction targets to try to initiate projects to bring companies to our region. As I said, this grew out of this is all about the Northeast Ohio Additive Manufacturing Cluster. We roadmapped that a couple of years ago, clearly with America Makes in the region. America Makes, if you don't know, is the national innovation center for additive manufacturing funded by the federal government, and that's right in Youngstown, Ohio. So that's a core asset right there. Our other partners in this are the Youngstown Business Incubator, which one of the leading incubators in the country, and it focuses mainly in 2 topics: software and additive manufacturing, nurturing a number of startups. And then Magnet, which is our regional MEP, which also has strong expertise in additive manufacturing. And the maps here, if you look at them and you look at, first of all, a snapshot of America Makes membership down there in the lower corner, you see how concentrated it is around our region. And then when you put real key additive manufacturing, either technology development or key centers of additive manufacturing in the country, you see again we're right at the center of a number of them. And so this is a great place to be in additive manufacturing. So let's dig into that. First of all, 3D printing, you've all heard that term. Additive manufacturing is often used synonymously with that. So if people are talking about 3D printing, additive manufacturing, think about it as basically the same thing. So 3D printing is a process where you create an object by starting with a digital design and then making a physical object to match that design layer by layer. You build it up. So it's not just one process. There are 7 main processes out there. The key benefits are the design freedom that gives you, that you don't have the constraints that you have if you're machining a piece of metal or injection molding a piece of plastic. 3D printing frees you from a lot of design constraints so that you can do things that just aren't possible with other ways of fabricating a part. It can also be a substantial reduction in time to market. It's very quick. You don't have to build tooling to do it. And it can also lead to production efficiencies if you use it in tooling. So we're going to get into it in the presentation that there's 3 ways to use it: making prototypes, making actual parts, and using it to do tooling. These are the 7 processes of additive manufacturing. I'm not going to read those all to you. I expect you to have them memorized. There'll be a test afterwards. But just know that there are 7 completely different processes that constitute 3D printing or additive manufacturing. These are all very different ways to fabricate a part, but they're all the same thing I just said. You start with a digital design and you build a part up layer by layer.
Is there somewhere in this region where you can access all 7 of these additive?
That bullet, was that bullet got lost on here? Is it on the next slide? No,
Okay.
It's lost.
Okay.
Yes, the Youngstown State University is one of only 2 academic centers in the country that has all 7 of those processes in its additive manufacturing center. It's a great center of excellence in the region.
Can I ask a question about those processes? So for each additive manufacturing project, you wouldn't necessarily use all 7 of these processes.
No.
Okay.
You'd usually be using one of those to make and design a particular part. And they each have their own strengths. Material extrusion is very quick and straightforward. Vat polymerization makes more structurally sound parts. Some of them are oriented towards metals, so they all have their different uses.
So when you have additive manufacturing machines, like we know there are some machines like at YBI. So does a machine do only one of those?
Just one of those. That's what I say. It's not homogeneous, right? There's 7 completely different processes that are called 3D printing, and there'll probably be more in the future. These are the 7 that people have invented today. So this slide I like because it lays out what I was just saying. You computer design something. You use computer automated design software to design a part. And then the software slices that into layers, like the piece of fruit we're looking at here. What is that, a pear? You slice it layer by layer, so the computer creates this image of it in slices. And then you print that part up from the bottom, a slice at a time. So a video is worth more than 1,000 words. So let's run this video here to demonstrate that on the next slide there. Not that one, no. Yep. The one that was on the oh, that's it, yes. Yep. So here you go. Here's one of the processes of fused filament, fused deposition modeling. And so you see, it's like a giant glue gun. It's going around layer by layer and extruding the melt of a plastic onto that and building it up layer by layer. And there you go, it's done. You've got this 3D part that you've just manufactured.
In real time, how long would it have taken to make something like that?
That would have taken hours, yeah, several hours. So that's one of those 7 processes. That one is fused deposition modeling. And this slide I bring up to tell you that back in 2009, people started to create really, really easy to use 3D printers. This is an example here. This one here is a 3D printer from a company called Maker Gear. You know where Maker Gear is located? Beechwood, Ohio. And they make this little FDM printer here. So you see it has a little filament that goes into this head and melts it, and you build up the part just like you saw in the video there, right? I'm showing you this slide because since 2009, the growth of the 3D printers has gone up astronomically because you have all these little machines, even less than this one, that you can buy for hundreds of dollars or a couple of $1,000s to use in your home. And so the numbers of those have grown exponentially. But we don't care. Why? Are we here to support the growth of your kid making toys in his garage? No, we're here to support industry. So when you talk about 3D printing, be very clear here now that there's home use 3D printing where anybody can make a design and stick it in this machine and print out a little piece of a toy or a piece of jewelry or something at home. But that's not what we're supporting in this cluster. We're supporting industrial uses of 3D printing, right? So ignore all those little home machines. That's not what we're about. So if you talk about industrial additive manufacturing, as I said earlier, let's reiterate, it's used in three ways, three purposes. One, you can make prototypes. Very important use that was the original use of 3D printing. That was pretty much all of 3D printing's use in its early days because it's a wonderful prototyping tool. You can have this little, you can be any manufacturer, designer, and you have this little tool sitting on the desk in your engineering group, and you want to try to convince your customer that they should buy your design. And so instead of showing them a drawing or a computer image of it, you can actually in a few hours just print one and show them your design, a real 3D actual prototype of what you want to make. Now obviously that's not the real shock absorber, right? It would be made out of other materials, but you can show them your design concept. Very useful, we've found, you'll see with plastic injection molders and people fabricating parts like that where they need a tool to injection mold their stuff. Well, often our injection molders in our region will design that tool, not to be made here. Most of them are made in China these days, unfortunately. But they'll design that tool and want to convince their customer to go with that design of the mold. And so they want to show that design to the customer. Well, they can print out a 3D prototype of the mold and show it to them. So prototyping, to be able to shorten the sales cycle on getting a customer to buy into your design, 3D printing is extremely valuable. If you don't use it, then you're not keeping up in part design these days because it's just an accepted tool. Customers want to see that 3D visualization. The second use is in making tooling. That can mean a jig, a fixture, a mold, a tool. It could be you've got a quality control lab and you need a fixture to hold the part so that you can optically test it. It could mean you've got a production line and you need something to carry the part down the line while it's being assembled and going through various operations. That fixture that you set the part on to hold it, you can 3D print. It could be you've got a line that's carrying parts off from a machine to go to something else, and you need little parts along the way to guide it. The little guide could be 3D printed. Or it could even be a tool, an actual thermoforming or injection molding tool that you use to make parts. So tooling is a rapidly growing use of 3D printing. This is growing exponentially these days. And then third, of course, you could actually print a production part, something you're actually going to use in a machine or assembly. Like here, we've got an impeller that somebody's 3D printed out of metal. As you see, prototyping remains the most significant use, but these two are growing very rapidly. This is a 2014 slide, and those are growing, especially tooling. So prototyping gives you speed to market. You can reduce the whole product development cycle time both in terms of your ability to iterate and look at designs and show them to your customer and close that qualification cycle. You can iterate designs in less time. It's less expensive than traditional methods. You can do it in-house, or you can use a local service bureau to do it. So who's your audience if you're trying to talk to companies that you want to make sure they're using 3D printing for prototyping? Well, any manufacturer who owns design authority, right? If you're involved in design, or if you're an industrial design firm, and as I said earlier, even a molder that's making a tool for their customer, anybody that has design authority like that, that's somebody that should be using 3D printing for prototyping, whether they do it in-house or whether they pay somebody else to do it for them. Secondly, direct digital manufacturing, making actual parts with 3D printing. This is the mind-blowing stuff that's going to transform manufacturing over the next decade or 2 decades, and it has been already, because it changes the way an engineer or designer should think. That young engineers and designers coming out of college today are trained to think in design in 3D. So holes don't have to be round. They used to have to be round because you had to machine it, or drill a hole with a tool. Well, if you're printing it layer by layer, it can be whatever shape you want it to be, and it can snake throughout a part. It doesn't have to look like what you think it had to look like. So it opens up all this design freedom. So you can, first of all, since you're making them one at a time, you can singulate, that you can design one for me and one for you and one for you. They don't have to all look the same. They can all be different. And auto manufacturers are already taking advantage of this. You buy a new BMW, Audi, a bunch of cars now. Then when you go in to buy the car, they say, oh, well, these 6 parts on the interior, we're going to customize for you, Melinda. What color would you like this one? Would you like us to have your name on this plate on the door? Because they can just print them, and it's very inexpensive to make them individualized to the customer. You can make parts more efficient and lightweight. Like this example here from GE. The Airbus now is using 30 metric tons a month of material, of additive manufactured parts inside their airplanes. 30 metric tons a month, because you can save weight, first of all. I mean, you think about a door bracket that looked like that and now it looks like that. Well, you've just saved a lot of weight, which of course is important in an airplane or a car, for that matter. So you can save weight, but yet this part will be just as strong and functional as that part, because it's been designed in 3D to optimize its performance. So lightweighting is a big deal. You can avoid the cost of tooling. To injection mold a part, you have to go build a tool for $100,000 plus, and then use that tool to mold the parts. Well, if you 3D print it, you don't have to spend that $100,000. You can avoid that.
When it comes to designing in 3D, would you say that this region is competitive, or are there other regions that are more competitive than us when it comes to utilizing 3D printing or design for 3D printing?
There's other regions that are competitive. This is a big deal. This is what companies are rolling out. But the joy of being in this region is, again, America Makes is a great asset. They've just rolled out a new program called Academy. And Academy is this really intensive 5-day course on designing in 3D with metals. And then they're going to follow that on with things for polymers and that. So you've got that. Then at Case, you've got ThinkBox, which is the largest academic makerspace in the country, that has all these 3D printers and all these computer stations that every student at Case, every student at Cleveland Institute of Art can go and design what they're thinking about, and have it to go to ThinkBox, push the file in there, and the next day come back and pick up their design. So you've got that. You've got Youngstown State, which I said is a huge leader in additive manufacturing. So you have amazing assets in this here, and it's one of our working groups. DFAM is the term, Design for Additive Manufacturing. That's the powerful thing that's going to transform manufacturing in the future. So we have a DFAM working group working on educating our local manufacturers in how to think in 3D. So this bullet here is very important. Well suited to small volume production. If you go on to the next slide, So this isn't ideal for everything. If you're going to make millions of parts, all the same design, just crank out 1 million of them, then 3D printing is not the right tool for you, because you can create that mold with injection molding or whatever you're going to do with metal fabrication and make the part cheaper if you're going to make 1 million of them at one time, because you can amortize that $100,000 for that tool across 1 million parts. If you're going to make it in small volume, that's different. So small volume markets are the right markets. So that's healthcare, aerospace, the tooling aspects that I was talking about, dental, jewelry, automotive, no, because automotive, there's millions of parts made, so it's a subset of automotive. It could be a large truck or custom small run size automotive. So yeah, if you're building a Lamborghini or an Aston Martin, they're using 3D printing to make parts because they're not making 1 million of one design, right? So here's an example of a local example of a beautiful use.
Coffee or their normal routine, and you go to a counter and you get that product. What was done to enable that product to come out?
This is the founder of Carbon, one of the fastest growing AM machines.
The little things are the things that really impact so many aspects of our lives that we often oversee and don't fully appreciate. If you can design a product on the means of production, in many ways it puts the customer front and center. The nozzle from Vitamix is absolutely a perfect example of the idea of fusing design with manufacturability and engineering all into one.
Ladies and gentlemen, I'm going to give you a demonstration of one of the most wonderful machines that was ever invented, the Vitamix machine.
Vitamix was started 97 years ago by my great-grandfather with a vision to see if he could help people eat differently.
Without help, you're a miserable failure.
We decided that if we're going to make a piece of equipment, we wanted it to last for a really long time. So we have never compromised on quality, and we won't.
The nozzle is actually part of a system that's used to rinse out containers. We were struggling to produce a multi-piece design that would stand up to the pressures that we were encountering.
We have the opportunity to do something right simply because it's the right thing to do and it's part of who we are.
And so we opened up a project to say, how could we redesign this?
Maybe traditional manufacturing isn't enough.
We recommended using the Carbon process as a start for the prototyping phase.
This product, when it was made by injection molding, actually had to be made out of 6 parts.
Making it a one-piece nozzle was really the only solution. The only avenue we had was the Carbon process.
When you make it out of one part, because we now can with digital light synthesis, you get a chance to dematerialize it. It's a third less mass.
Vitamix started testing the prototypes and found that the material was durable enough to meet or exceed some of the injection molding materials.
It actually has exceeded the quality standards of the product that we were able to make on traditional manufacturing.
You can't afford to go another day without a Vitamix machine.
If you're going to believe in something that isn't yet possible, then you have to rethink possible. It's the only way to get there. So the partnership with Carbon is very exciting for us because it's helping us rethink the possible every day.
For the longest time, we've been sending all these engineers to classes that are design rule classes. These are all the rules you have to follow because you can't do stuff.
Once you can manufacture something differently, then you can think about how those components interact with other components. Then you can get an entirely different outcome.
It's about evolving the paradigm of engineering. Now we have a new tool in the toolbox that we're learning, exploring, evolving.
This is a cultural revolution on how designers and engineers think. Once you go digital, you can't go back. It fundamentally changes how people collaborate and work. You don't have to have the constraints of manufacturability superimposed on the design. Instead of being curtailed on your idea because you couldn't make it, now you can make it, so you can let your imagination run wild. It changes everything.
So that's Carbon, a Silicon Valley startup that has upwards of $300 million in venture capital in it now, a lot of that from Google. And their success story is a Vitamix nozzle for the Vitamix from Olmsted Falls, Ohio, manufactured by the Technology House in Streetsboro, Ohio, which is the leading carbon service bureau in the country. They have 6 carbon machines now, five carbon machines.
Just there.
So this region is a leader in additive manufacturing technology. So there's lots of things you can do. These are examples in our region of companies doing direct part production between Parker and GE Aerospace in Cincinnati and AFRL, a lot of aerospace, a whole lot of aerospace. Arconic is huge in this respect in terms of metals that are used in AM production in aerospace. Parker has a additive manufacturing innovation center in Macedonia that they're using to roll out additive manufacturing in a big way throughout all their operating units because they understand the power of it for many, many uses. And then in biomedical, you've got a number of really interesting uses. The Cleveland Clinic uses it for patient-specific tissue modeling. QED works with the Technology House to use it to make housings for their MRI coils. Slice is a great startup in Akron that's making metal hip and joint implants. So you have a lot of activity in direct part production in Northeast Ohio. Third use, right? That was prototyping, direct part production. Tooling is the third use. This is significant across the manufacturing spectrum, right? Because this is not something where you have to go get approval from your aerospace customer to use 3D printing to make a part for them. This is just making stuff to use on your manufacturing floor, right? So you don't usually need qualification for that. And so why, and it's compatible with your existing stream. So why aren't companies doing that? Well, they don't necessarily understand the technology, so they're risk averse, so they don't know how to use it. And they may need to train some existing workforce. So I'm going to tell you about a great program, ATAP, that helps them understand how to do that. Who would be the targets that you would want to talk to about this? First of all, plastic processors like injection molders, thermoformers, extruders, where they can use it for tooling and jigs and fixtures in their factories. Metal fabricators that are doing milling and machining and turning traditional metal fabrication. Tool and die shops where it can be used for pattern making. A special subset, metal casting, is a big success story in Northeast Ohio with a company called Hometown Products. That American Makes taught them how to use it to 3D print sand casting molds. And so they're the leading company in the country in terms of printing sand casting molds using a machine that comes out of Southwest PA, Southeast Ohio, called a company called X1 that makes the machine. And then manufacturers in general. I mean, like the examples I gave earlier, of a fixture that carries something down the line or in quality. Well, that applies to any manufacturer, really. But look at these numbers. Just know this about Ohio, that these are numbers about the number of establishments of these kinds of companies in the region and our location quotient. So you see there's tens of thousands of target companies just in our region. It's very easy to identify companies that can save money in this way. So if we go to the next slide, that's a start. Sorry. These are some of the examples that we identified in doing the case study examples that we've identified in doing the roadmap and then subsequently with ATAP. So Honda down in Marysville uses additive all over their factories now in terms of tooling. The automotive industry has adopted this in a big way. Ford, Honda, Toyota, all of them are using additive for tooling and jigs. Like if they're setting up a new line and they want to try it out and they need to run something down to get the line lined out, they'll print a bunch of the fixtures and parts and carriers and everything to try it out, and then use those as setup tools to run parts down a line, and in quality on that. there's a company in Akron. I'll tell you about them in the success stories a little later on. But blow molding, tooling, fixture. There's a window profile company down in the Youngstown area. So you make window profiles. You extrude these pieces of plastic, and then you need to line them up to glue them to make a nice square window. So you need a fixture to hold them all square, but each one could be a different design if you're making different models of windows. So you could machine those fixtures out of a piece of steel and waste a bunch of steel in the process and spend a lot of time doing machining. You can just print that fixture for a fraction of the cost. So they do. We taught them how to do that. The mold inserts, inspection fixtures for pumps. So there's just endless examples of how to use additive in tooling. And we think for Ohio, it's really significant. There's so many tool makers and plastic and metal processors here. So we have this great state-funded program that we have to take full use of. It's called ATAP, Advanced Tooling Acceleration Program. And basically it's this. For that audience I was just talking about, those manufacturers, that we have these amazing AM technology experts in the region. Dave Pearson at Magnet has 25 years of experience in additive manufacturing. He's a known guru. He teaches additive manufacturing at military installations around the country, as well as at Cleveland State and Tri-C. Then down at American Makes, you have all these great experts. At YSU, you've got professors like Darrell Wallace, who's available through this program, who's an industry-renowned 30-year additive expert. So in this program, we bring one of those world-class experts into your factory. They walk the floor with your people and walk around and identify use cases for you where you could save money, drop more profit to the bottom line by deploying additive for tooling on your plant floor. And then, once they've identified a use case, then so that you don't have to spend money trying it out, we de-risk it for you, that then we identify a local service bureau that can print that part for you, and the grant pays for that first job to be printed for you up to $5,000. So you identify some piece of tooling on your floor that instead of making it traditionally, you could make it with additive. They help you design that, get it printed by an outside bureau, put it into use in your factory, usually at no cost to you, because most of these don't even cost anywhere near $5,000 to implement. So it's teaching them how to do it, how to deploy additive, and then showing them local vendors that can do it for them. Because in the hype of additive a decade ago, some manufacturers bought additive machines but then didn't know how to use them. We don't advocate necessarily the company buying an additive machine right away. We teach them how to use the local vendors to deploy it first, and then if the economics make sense, then purchase a machine. And even then, we have these experts that can guide you to the right manufacturers.
Tim, one question about ATAP. Is it run through Third Frontier? And is there an end date to the program?
Yeah, it's a state AMP grant.
Okay.
So that does come through Third Frontier, I believe. It's an MEP program.
Right. Yeah. I saw your logo there. So is there a certain time frame of
Yes.
this program? Is there
Yes.
a sunset to it, for example?
Yeah, it was going to have a sunset in June, but the state gave us an extension to use the rest of the funds. So it's going to run at least through the third quarter, maybe through the end of the year, but it's something we need to take advantage of now.
Okay.
But even at the end of, so take advantage of it now. When it ends, when in our tooling working group, we're going to assemble those local vendors into a supply chain collaborative and continue to provide this kind of service, but without the state subsidy on it. So, but now is the time to take advantage of it. I won't belabor this slide. It's just showing you, as we talked before, the key markets for additive manufacturing and the way in which additive is used there. I'm not going to go through all of that. That's just some background for you. The last opportunity to make sure you're aware of with additive in our region, as you know, our region is incredibly rich in polymer materials companies. There's, 10 or 12 multi-billion-dollar companies here, and a lot of others. And they haven't come into additive manufacturing and utilized their assets to develop materials for additive so much because there were some barriers there. There were closed systems, there were patent restrictions put up by some of the machine companies, but a lot of that is running out. Stratasys' core patents ran out, and there's a lot more open machines on the market, so a lot of polymer companies are jumping into additive manufacturing now. when you see numbers like Airbus consuming 30 metric tons a month, then it gets their interest. And so this is something that our local polymer companies need to take advantage of. So large companies like DSM and Owens Corning and BASF, many of them are jumping in with lines they've developed specifically for additive manufacturing. In our region, A. Schulman and PolyOne have been in it on a tolling basis. Lubrizol just announced recently that they're entering the market. They're going to be one of HP's partners to develop materials for HP's machines. And we have 2 filament producers in the region. Remember, filament used in FDM for the little glue gun type process. We have 2 of those in the region, one in Norton called Keene Village Plastics and one in Chesterland called Filament. And then AM Metal, the last bullet on there, AM Metal powder. So if you talk about making parts with metals, you would spread a powder bed and fuse it together with lasers or other things. So AM Metal powder is another big, huge growth area. We're not really a metal powder rich region, but that's an attraction opportunity. So speaking of attraction, here's my one attraction slide in this deck. And this is the slide we use when we go out to talk to companies about why, if you're in additive, you should be in Northeast Ohio. First of all, you got that amazing infrastructure here. You got American Makes here, which is the innovation center for additive for the entire country. You have all those processors I just showed you in that one little chart that you've got, you know, more than 1,900 metal fabrication and plastic processors here. So there's a built-in customer base right there. If you talk about end-use markets for additive, it's primarily the biggest ones are aerospace, medical, dental, and automotive. Well, those are all here. Those accounted for 62% of AM sales in 2014. So the end-use markets are here. We've put together this fabric of local organizations and a cluster, so we make it really easy to meet all of the assets associated with additive in the region if you come here. We've got great workforce and R&D capabilities here that you've got, you know, workforce development programs at Cleveland State and Lorain County Community College and Stark State, and, you know, 2 leading universities in the country in additive in Case and YSU. So just all sorts of support resources here. And you've got some world-class firms here, 2 of the best, probably maybe 2 of the top 5 service bureaus in the country that are not owned by some big conglomerate are here in the region. The Technology House in Streetsboro and RP Plus M in Avon Lake. So, you've got a handout. Can I have a handout?
Here.
There you go. So this we did for the last partners meeting, right? That of questions to ask when you're talking to companies trying to find out if they are fit for additive manufacturing. So we're not going to go through every detail, but you see there in the categories we talked about there that plastic processors and metal fabricators. You know, do you already have a 3D printer in your engineering group? Do you use it to make prototypes? If so, why aren't you using it to make tooling? You could save yourself a lot of money. Let us help teach you how. If you don't have one, well, let us teach you how to make tooling anyway. Jigs, fixtures, QA tools, etc. How do you make them today? Do you buy them on the outside? Would you like to learn how to save thousands of dollars in tooling costs by using additive? And then tell them about ATAP and what I just explained to you. Metal casting companies, a subset of that. There's very detailed supply chain and content available in the region on that. So if you're doing a metal casting and it's really low complexity, really simple, then yeah, you should probably just mock it up in cardboard or whatever you're doing today. If it's of intermediate complexity, we have a company in Youngstown that can FDM print the what's it called? Not the tool, the precursor to the tool. The pattern. You got it. The pattern. They can print that with FDM for you. If it's a really complex sandcast tool, where you might have, they're like a puzzle where you cast like 12 different pieces, and then you have to put them all together into some complex pattern. that's where you 3D print the whole thing using Hometown's technology, because you can just print it in one part and be done with it. And they typically reduce the cycle time on that to get to production from like 16 weeks to 4 weeks. I mean, it's huge. General manufacturers in terms of, using it in design, and then materials manufacturers we talked about a moment ago there. There's many success stories, many success stories. Hometown I just touched on has this giant sand cast printer that you can print tools for metal casting. That's a great success story caused by American Makes being here. AES is one of my favorites. That's Additive Engineering Solutions in Akron, north side of Akron. They're one of the startups that I mentor. They started a little over a year ago, I think like January, February 2017. They are the only BAM service bureau in the world. BAM is Broad Area Additive Manufacturing. It's the largest additive manufacturing machine in use today. That the build platform for a BAM machine is like 6 feet by 6 feet by 10 feet, something like that. So you can print this entire table inside that machine. It's huge. So those machines are not in heavy use out there. They're very expensive, and so most of them, not all of them, except theirs, are captive, like inside a GE where they just make parts for themselves. Except this one in Akron, they have 2 BAM machines now. They are killing it. They started a little over a year ago. They've done a lot of revenue in their first year, very successful out of the gate. And what they're making is they're making tools for making really large parts. So like in aerospace, if you want to make a big part that's, it's a composite plastic part that's part of a wing or something, you have to have this enormous tool that you're going to hand lay up the material in, the carbon fiber loaded plastic, and then put it in together and heat it and cure it. So you need this enormous tool. So it can be incredibly expensive, hundreds of thousands of dollars for machining a tool out of metal. So now they can just print it for you, and it's drastically cheaper. And so they've been doing a lot of work in. So you can think about large parts: aerospace, automotive, a boat, right? You want to make a boat that's a part for a boat that's 6 feet by 10 feet or something. You can just print it, the tool, and make the part that way. So they're growing tremendously. The other one is in construction. If you think about making cement blocks or something like that, those tools that they pour the cement into, well, they can make those really cheap too. So they're growing wonderfully. Great success story. Freshmade's a little company that makes a unique process for making tooling, so they can make tools for our injection motors and that. They'll be coming up here this week. So part of what I do there is introducing them to customers. So I'm going to introduce them to 3 of our industrial designers here in the region as potential supply chain partners, clients for them. But there's endless success stories in our region. It just goes on and on. Velocity was one that wanted to make a decision about whether they should buy a metal printer. They're not even in Northeast Ohio. They're down in the southern part of the state, in the Columbus area, and they came to a show here and knew about our cluster and asked, can we talk to you because we need help with some decisions. So I took Dave Pearson to meet him at a trade show that was here recently. We gave him guidance on, no, you don't need to spend $1 million on a machine. Here's all these vendors out there that can help you locally. Upcoming events, where's Melinda?
So we have a Ceramics Expo coming up in May, and then we have some conferences coming up in the next 3 quarters. So on the next slide, if you subscribe to our newsletter via our website, you will get all of the dates when those are set. So please visit us, website and Facebook, and you can reach out to me for membership, events, marketing questions. Tim's a great resource for, like we talked about, the ATAP program, and Tim really specializes in supply chain connections, so really great at helping match-make companies. He's definitely a resource that we want to deploy to everyone to be able to tap into.
Thank you. Thank you, everyone.